It's just down there.
Where is it? Okay, I guess we are all in the same page now. Let me do the... Okay, so in our last class, we discussed about the history of R programming language and its various case use. We discussed how to download R. We discussed on one use case of R, using R as a calculator. We discussed about variables, data types, data objects, and data operations. We discussed about functions, and I think this is where we left on functions. A brief history of R. I think we are all now familiar with this. Those who attended, we said R was built by Rosie Hack and Robert Gentleman. It's a free software. How to download it? This is how you download it. Then after that, we went straight to one use case of R, using R as a calculator, where we did all these arithmetic operations using R. We did them practically. Then we went forward and discussed about variables. We said variable is a container. You can always remember a variable as a container, but the right definition is this: a variable can be defined as a named unit of data that is assigned a value. So why do people refer to it as a container? This is because it holds something. It holds something, just like you can take a gallon, pour some water. So the gallon there is the variable. The water are the entries. So we discussed about that and how to assign variables. In R, we say there are two conventional ways: using equal sign, then using less than and the small dash. Okay, we went to talk about data types. Data types, we talked about numeric, integers, logical, complex, character, and how to identify what class a variable belongs to. We used class function. Data types basically are just the data that you enter in your program, how R interprets them. A piece of data that instructs a computer system on how to interpret its value. Then we went and talked about data objects. Data objects in R are vectors, matrices, lists, data frames, and arrays. We also did them practically, how to make vectors in R, how to make matrices in R, what are lists, what are data frames, the types of that data that they can all store. We said vectors is one-dimensional array, matrices two-dimensional, a list, data frames, then arrays. Then we went and talked about the functions in R. Functions, we define them as a set of statements organized to perform a specific task. Then we discussed about the syntax for R function. This was the syntax. We explained. This is the function name. Function, you call function, then arguments, then the function body. Okay. Control flows, this we'll discuss today now. I hope that is enough of the recap. And now everyone is up to date. I'll share the other screen now of what we are to discuss today. If you have any questions up to there, just write them on the chat box. Are we together?
Yes, we are together.
Okay, thank you.
Okay.
Has Jeremy arrived already, Emma?
Not yet, but Jeremy, you around? Say hi.
Okay, I think Jeremy, if he's around, we'll go through this together.
Okay.
There are about 20 slides. but if I get tired along the way,
Jeremy will take over.
yeah. So,
We'll see what to do.
okay, let's begin. So today we are going to talk about conditional statements, loops, and functions in R. Okay, now let me define to you what conditional statements mean. In R, conditional statements, hello. Hello, is that Jere? Okay, let's proceed.
Yeah, how are you doing?
It's going fine.
We are fine.
Can you see that?
Hello.
Hello, I had some technicality problem.
Yes.
So say nothing. Hey,
Okay, Jeremy, we can't hear you well, but you can mute.
Okay, I think you've all heard Jeremy. He had some small issues and I think the network is still unstable, but he will join us very soon. So let's proceed. We were talking about conditional statements in R. So to define a conditional statement, you can say conditional statements are used to check if certain conditions are met. If certain conditions are met, that means that you can write a program to state to it to only run if some conditions are met. And in R, these type of conditional statements. We have if else, then we have nested if else. Okay. Now we'll proceed to the next slide. If else statement. How does if else statement operate? So an if else statement, what it does, when the test expression is true, the code in the if block executes. Otherwise, the code in the else block executes. What do I mean? Let's look at this example. Now, here we have assigned a variable named age, a value of 20. Then we are now down here. Yes, we want to describe an if else statement. Remember, if else test expression, it gives result if a test expression is true, if in the if block. Otherwise, in the else block, it also executes. Now, let me explain using this. If age is greater than 18, print major, else print minor. What does this mean? If our variable age, which we have clearly defined here as 20, if it's 18, our program should output major. But else, if it's not 18, it should output minor. Are we together? Okay, let me do that very first here on R. Need a new. If now we are going to assign a variable age, a value of 20. First we run this, control enter. Now we'll now create the conditional statement using if. Now we'll say if in brackets age is, let's say, is greater than or equal to, we say 18, print major, else print minor. Let's run that. Okay. Okay, you can see on the console window that we discussed last time, it prints out major. This is because the age variable that we assigned is 20, but in our if else statement, we say, in our if else statement, we have defined if the age is greater than or equal to 18, it should print for us major. Else it prints minor. So let's take, for instance, we have a, let's say if age, no, let's leave it at 18. Now let's take the variable age, let's assign it 11. Run that one first. Then let's run the code for conditional statement. You can see we have described our age as 11, but in our conditional statement, we said age should be greater than or equal to 18. The output should be major, else it should print minor. So that is how if else works. Okay, let's now proceed. Oops. Sorry. I keep forgetting about this every now and then. I'll repeat. Let me pick this one. Okay. Hope you're all seeing now. Susan, please confirm if you're seeing it now. Thank you. Okay. So I was describing to you guys how if else conditional statement operates. If you assign a variable, say age, a value of, I started with 20, then you first run that line. Then you come down here, you define the conditional statement. In my case, I defined my conditional statement as if the age that we have assigned above here is greater than or equal to 18, my program should return major. That's why I've defined it as print major. Else, if this is now less than 18, it will print minor. It does the opposite now. If that condition is met, it prints minor. And I ran this, control enter. You see the result is major because I've assigned this age variable a value of 20. Now let's take, for instance, we have assigned this value as 15. Let's run that. Then let's run our if else statement. You can see the output now is minor. So that is how if else work. Okay, let's proceed to the next slide. Yes, if I now remembered it. Okay, now there is this other type of if else where it's if else. The two words are joined together, if else. This is the main thing to check, if else. We can describe it as a vector equivalent form of if else. So let me describe here first, then I'll demonstrate. Here we have assigned age a value of 20. Then we have said if else age is greater than or equal to 18, major, minor. This means that our program will run this statement. First, it will execute if our first argument here is correct. Else, it will execute the second argument. You can see the difference. The other one we wrote if, then we defined age, then we gave it the argument print into bracket major, then we came down and said else, then defined the argument. But this one will use if else. Let me demonstrate it. Where is it? Correct. Now, let's say if else. in bracket age greater than or equal to 18, then enter. The first argument is major, then followed by minor. Let's try this out. If it runs, you can see it runs and the output is minor. Why minor? Because our age variable is assigned a variable of 15, and in our argument, in our function here, we said if age is greater than or equal to 18, it prints major, else it will print minor. So this one is less than 18, so it printed minor. Okay. Are we together up to there, guys? I know it might be difficult to absorb this at first, but as you do it regularly, it's easy stuff. Are we all together?
Yes.
Okay, thank you. This is switch statement, but I'll return to that slide after discussing something here. Let's talk first about nested if else. Then we go back to switch statement. I think you'll get it better that way. Okay, there is nested if else statement. Okay, so in programming, we say a program or a block of code is nested when we have various steps included in that block of code. We want multiple execution done at a time, but we define them inside a single function. Like for instance here, x is greater than x equals to 0. Then we said if x is greater than 0, print negative number. Else if x is greater than 0, print positive number, else print 0. So you can see we have this argument here, x greater than, less than 0. Then we also have this one, x greater than 0. So we are trying to tell our program to run multiple lines at a go. So if we assign a variable x a value of 0, then we now call this function. It should output 0, because in this statement, in the first argument, we said if it's less than 0, it prints negative number. But 0 here, it's not less than 0. If it's less than 0, it means it will be negative number. Then we also said, else if x is greater than 0, print positive number. If it's greater than 0, our variable is at 0. It's not greater than 0. Else print 0. You can see it printed out 0. This is because our value here was 0. Let me demonstrate that one also. Okay, we'll still use our age variable. Let me, this is if else, then we have nested if else. Then we have seen there is new known as else if. Okay, now let's try it out. Let's say if age is greater than 10, print it's about 10-year-old kid. Will say let's say good boy. Let's also define, let's now add else if brackets, now say age is less than 10, print small boy. Then you can add other arguments. Let's say again, else if age is equals to 15, print, let's say, adolescent boys. Then else, this is now the final argument. We'll say now else, print hello. Out of words. Okay, now we have age as a variable already. We have run the line. We ran this one earlier on. Let me just do it again. Then now we want this one executed. If age is greater than 10, it should print out good boy. Else if age is less than 10, it will print small boy. Else if age equals to 15, it prints out adolescent. Else print hello. That means if all these lines are not correct, it will print out this one. So hello. So what R does, it runs these commands from up. It starts from up to the bottom, not bottom up. It starts from up to bottom. If line 1 is not correct, is not found, it prints nothing. Line 2, line 3, then to the final argument. Now let's try to run this. First, you can highlight first, then control enter. Expected symbol in good boy. Okay. Let me just confirm that. I think we made a mistake there, but there is no problem. I'll correct that. Get back here. Okay. Else if I'm used to Python. Python writes this as elif in short, and you get your answers. So I concatenated these ones as else if, but I think they're separate words. Now let's run this. Oops. Less than 10, boy, print, else if. There should be commands. Let's try that. Not yet. Who is seeing the bug? Hello.
So,
Can you guys point out where we are wrong? You'll get used to this. Even missing a single comma in your code won't make it run. Let's try that. Else print hello. Let's run that again. Unexpected equal in print small boy age.
Double equal sign.
It should be double.
Double equal sign.
It should be double, yeah? Double is, yeah, if you use a single equal sign in R, it means you are assigning a variable a name. But if you say z equal, it means it equals to this.
hello. Yeah.
Okay? Now let's try run it. Yes, you can see our output is good boy. I forgot to tell you about this. When assigning a variable, you use a single equal, and when you want to say something is equal to something, you put double equal sign. So you can see, I forgot, I used one equal sign and my program didn't run. So you have to be very keen. Okay, now let's see our output. Our output is good boy. Is that right? Yes, we said age is 15. And here we said, else if age equals to 15, our program should print adolescent. And you can see, which line did this run? Good boy. If age is greater than 10, yeah, I told you guys it runs from above. So you can see it has only run this line, the first line, which is age is greater than 10. Now, let me give this one another condition. Let's say it's greater than, let me say it's greater than 18. Should print good boy. Now it will run this this third one. It will run through the whole function from up to bottom. Now you can see our result is adolescent. It has jumped to this other third line. Okay. We can now proceed. We now get to loops in R. Loops basically are iterations. Those iterations, repetitive actions. Like say you want to print a list of 100 digits, you can use loops to print those digits. So here we defined a loop. A loop is a control flow statement that executes a statement or a group of statements many times. Yes, many times. I said iterations. It makes iterations. So in R, we have for loop, while loop, and repeat loop. We'll discuss them all. Let's go ahead. I think we have 7 minutes. We can still manage to discuss even for loop. Okay. The for loop executes a code a specific number of times. Here is an example. I'll explain it. Here you have assigned a vector. You labeled it as vector C. Remember we said to assign a vector, you have to use C, concatenation function. Then here, he applied for loop. He said, for values in the vector, print value. It means it will return all the values in your vector in that order. Now, we can do it practically. Let me show you guys how to do it. Where is it? Where is the screen? Are we together, guys?
Yes, we have to get that choker.
Okay, thank you.
Okay.
Okay, we can now assign a vector, let's say BR. And remember C, you have 22, 34, 56, 76. Now you want a for loop to print them down. List-wise, we'll say for values in BR print BR. Let's run this one first. As you can see, it has provided us with a list of items there. Iteration. The first iteration, we can see it here, second iteration, third up to fourth. Remember here we had 4 indexes. Okay, that is how for loop works. Let's look something advanced about for loops. I think we didn't note it here, but for loops, that is basically how it works. Hello? Now let's look at while loops. Remember we said there is for loop, while loop, and repeat loop. Jerry, are you there? Or you'll pick up from second session? Okay, let me proceed with those 3 minutes. We can cover up this one also. So while loop, in the while loop, while the test expression remains true, the code inside the loop keeps on executing. Okay, just iteration stuff as we said about loops. You can see here, he assigned a variable I1, a value of 1, then he defined his loop as while I is less than 6, print I plus 1. So what it will do, it will be adding one in on this I. So remember we have I as 1. We have said I equals to I plus 1. So in our first iteration, it will be 0 plus 1. No, yeah, 0 plus 1. Then we have 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. First iteration, remember indexing in all programming languages starts with 0. So in the first index, it will be 0 plus 1. Like defined here, we have I is equals to 0 now plus 1. Then we have I in the first iteration, 1 plus 1, 2, that way as you proceed. Let's define this one also. Where is the screen? Say I, we gave it a value of 1. Let's first run that. Then say y. Oops, our time is almost. But I is to 1. That's the real thing, really. Let me confirm. But I. Oh, you first define the number of argument iterations you want. I less than 6. The number of iterations you want to make. There is brackets. Print I, then define your iteration, say I is equals to I plus 1. Now let's run this one also and see the output. You can see the output on console. We have 1, 2, 3, 4, 5. Let's say we assign this one as 2. Let's see what it outputs. Let's give it I plus 2. Still outputs nothing. Have I run this one really? I equals to that. Then let me run this one now. Highlight it all, Control Enter. You can see 2 plus 4. It can't exceed the 6th value. Okay, I think we'll proceed there. We have 1 minute left. We have 1 minute left. So you guys, in the next session, we'll start with questions. What you didn't understand in this first session, we'll revisit it, then proceed as time goes. We'll start with, we'll dive into